What's up, YouTube? Durbador Weldor here, coming at you with another video. Today we're going to be making a new gem hole crane. It's not for the 350. The one for the 350 works fine. This one's going to be going on another truck of mine. This is going to be going on my 89 F-150. It's been needing some work, and I've been trying to make something out of that truck, so I've decided to make it into a little off-road tow truck. Now, my first gem hole crane I built, I did not really take advantage of mechanical strength and interlocking pieces as much as I could have. So this new version, I made the pipe interlocks into the I-beam, the I-beam interlocks into the pipe, the actual end where everything hooks up, interlocks into the pipe. It's a much more well thought out design. And also all of my pieces that I put on the truck itself are plasma cut on my CNC table. So everything has a really nice, clean look to it. It just looks super awesome. So here you can see I'm taking advantage of it locking together mechanically, getting it all to lock together. It really works out a lot better when it's not just the weld making the strength, but the actual build, the fabrication, the way it's designed, all the parts interlocked together along with a good weld. And I dual shield welded all of this because it's just way better. It's not better than stick welding, but it's better than MIG welding it. It's stronger, it's going to last longer, and of course, my camera bipod here is screwing up. But I used my Prime Weld Cut 60 to plasma cut all of these parts. And I used my Lincoln Power MIG 210 to weld them all up. And this right here, this is my new MIG gun. This is the HTP replacement for the Lincoln Power MIG 210. Here's the winch I'm using. I'm using a Harbor Freight Badlands 12,000 pound. And for the chain attachments, I'm using 20,000 pound rated D-rings. It's a lot stronger. This whole build is 100 times better than the one I made for the 350. Which is funny because now I'm turning around and I'm putting it on a half-ton pickup. The winch plate here, I programmed into the plasma table and cut out. So no hole drilling or anything like that. Welded it to a 2-inch receiver bar. We'll see how that does. It's just an idea. This is just the idea to see if I can make this work. Here's our D-rings with the plate, and the plate's welded to the frame. Big heavy D-rings, I think 20,000 pound rated D-rings is what I got. And here we go, you can see there's the crane put up there. You can see my plasma cut brackets that are welded to the frame, all my plasma cut pieces that all lock together and look really nice and clean and neat. Having that plasma table makes making stuff like this a whole lot easier, much easier to make it look neat, clean, and consistent. And even got it to where this actually folds over the box. I don't have a cradle for it yet, but it does fold up and pack down neatly, which I couldn't get it to do with the other one. You can see there's my set of pulleys I got right there. That just helps add extra strength to it and divide the weight up among different areas on there. And I just use snatch blocks because snatch blocks are well beyond overrated for what I would be lifting. This setup I'm making to lift 6,000 pounds vertically, and those pulleys should do just fine. Now the winch being back there requires a lot of cabling. Best thing to do, buy a cheap set of 1-gauge jumper cables, cut them off, and put the connectors on you need to. It's less than half the cost than going and buying the appropriate size battery cable, and it works out just great. That's what I did. Saves a lot of time, saves a lot of money. Thank you guys for watching. Please like and subscribe.